Hey everyone, and welcome to this explainer. I am absolutely thrilled to have you here today. If you're a focused learner looking to truly grasp how modern software gets built, tested, and shipped at lightning speed, you are in exactly the right place. We're going to dive straight into a structured journey exploring modern software integration. Specifically, we're demystifying the absolute powerhouse that is Jenkins and seeing how it actually stacks up in today's 2026 landscape of automated delivery.
Okay, let's dive into this. Picture this. What actually happens when a team of developers merges their code updates 10, 20, maybe even 50 times a day? In the old days, manual code integration in large teams was just absolute chaos. Imagine trying to weave together dozens of different, constantly changing copies of code into one shared repository without breaking the whole thing. It was this tedious, error-prone nightmare that killed release schedules and introduced massive bugs. We desperately needed a better way.
Well, that better way is CI/CD, continuous integration and continuous delivery. You've probably seen this infinity loop before, and it perfectly captures the concept. Continuous integration is where developers frequently commit changes to a shared repo, and then each of those commits is automatically pulled, built, and tested. The whole goal here? Rapid feedback. If a bug slips in, you catch it instantly. This continuous loop is quite literally the ultimate solution to all that development chaos.
All right, Section 1. Meet Jenkins Automation Server. To make this infinity loop a reality, we have to talk about the pioneer of this whole automated pipeline concept.
Meet Jenkins. You probably recognize the iconic Butler logo. Jenkins is an open-source Java-based automation server, and honestly, the best way to think about it is like the conductor of a massive DevOps orchestra. It stands right at the center, making sure all the different instruments, your builds, your testing frameworks, your deployments, play together in perfect harmony. Without that conductor, you just have a bunch of noise.
Now, it didn't just pop up overnight. Jenkins has this incredibly rich, battle-tested history. It actually started way back in 2004 at Sun Microsystems under the name Hudson. Fast forward to 2011, there was a bit of legendary tech drama, a big dispute with Oracle, and a project was successfully forked and renamed to Jenkins. And here we are in 2026, where it's still serving as a dominant, totally resilient backbone for CI/CD pipelines all over the world.
Moving on to Section 2, Controller and Agent Architecture. Now, what's really interesting about this next part is peeling back the hood to see how Jenkins physically operates.
At its core, Jenkins relies on a strict split between controller and agent. The controller is the brain of the operation. It handles all the management stuff, scheduling jobs, hosting the web UI, tracking your plugins. But here's the thing, it doesn't do the heavy lifting. That falls entirely to the agents. These are your workhorses. They're separate machines or even dynamic containers that distribute the actual build workloads across different operating systems like Windows, Linux, or Mac OS. This distributed setup is exactly how the brain prevents itself from getting overwhelmed.
Section 3. Freestyle jobs to pipelines. So how do we actually tell Jenkins what to do? Let's talk about how the industry shifted away from some major early growing pains.
Back in the day, the standard approach was using what Jenkins calls freestyle jobs. These were entirely defined right inside the Jenkins web UI. You'd click around, add parameters, paste shell scripts into these tiny text boxes. But here is the massive pain point with that. As your project grows, this manual method turns into an unmanageable mess. It's incredibly hard to track changes, you can't really review modifications before applying them, and troubleshooting complex dependencies between jobs, it's a complete nightmare. One wrong click in the UI and everything breaks.
So the crucial point is how we solve this. The industry completely evolved from those fragile, UI-based freestyle jobs into a much more modern solution, Jenkins pipelines. Instead of clicking through a web interface, your entire software delivery workflow is written as code. This code lives in a text file called a Jenkins file, which sits right alongside your application code and version control. It's versionable, it's reviewable, and it's just infinitely more reliable.
Let's look at Section 4, Anatomy of a Pipeline. I want to guide you through a real-time, step-by-step breakdown of how Jenkins actually executes this code. Imagine a real-world scenario. Step 1. A developer pushes their code changes up to Git, which instantly triggers Jenkins. Step 2. Jenkins grabs that Jenkins file directly from the repo and reads out the pipeline stages. Step 3. The Jenkins controller delegates the required tasks, stuff like compiling the code or running unit tests, out to its available agents. And finally, Step 4. The agent reports back. If everything passes, boom, it publishes your shiny new build artifact.
Now, when you're writing that Jenkins file using the groovy DSL, you actually have two syntax choices.
There's the older scripted syntax, which runs sequentially top-down inside a node block. But really, the modern standard today is the declarative pipeline. This syntax is enclosed in a pipeline block, written locally and checked straight into source control. It just provides a much cleaner, more structured way to define your stages, making it way easier for your whole team to read and maintain.
Section 5. Jenkins versus modern rivals. Now that we understand the mechanics, let's zoom out and prep you to make some strategic decisions for your team in the 2026 landscape.
Let's do a clear, totally impartial breakdown of the big three right now. On the left, we have Jenkins. It is the king of complex enterprise pipelines. Its whole philosophy is unmatched flexibility, driven by over 1,800 plugins and total self-hosted control. In the middle is GitHub Actions. That's built for GitHub native teams, focusing heavily on developer experience with zero setup and a massive marketplace of 15,000 actions. And on the right, GitLab CI. They position themselves as an all-in-one DevOps platform, loaded with incredible built-in features straight out of the box.
But, every single tool has its weaknesses. With Jenkins, that flexibility comes at the cost of high operational overhead and the universally dreaded plugin hell, where conflicting dependencies can literally ruin your weekend. Plus, Groovy has a pretty steep learning curve. GitHub Actions, on the flip side, locks you heavily into their ecosystem, and large workflows can get notoriously hard to debug. GitLab CI is amazing, but it's super resource-heavy if you're self-hosting, and a lot of the advanced features are locked behind some pricey premium tiers.
Then there's the financial reality of it all. Jenkins software is 100% free, but you are paying to power and maintain your own infrastructure. The upside? Uncapped concurrency, based entirely on whatever hardware you throw at it. GitHub Actions and GitLab CI both have generous free tiers, but eventually, you're paying on a minutes-based or per-user cloud pricing model. For really high-volume enterprise builds, paying per minute on the cloud can actually outpace the cost of hosting your own Jenkins servers pretty fast.
Section 6. Choosing your CI/CD future. So, where do we go from here? Let's outline a few practical steps for teams considering making a switch.
If you do decide to jump ship and transition from Jenkins to a managed cloud tool, be aware it generally takes about 2 to 4 weeks per major project. You have to be super systematic about it. Step 1 is mapping your existing Jenkins file stages to the new platform's specific workflow format. Step 2 requires you to go in and carefully swap out all your custom Jenkins plugins for native marketplace actions. And Step 3, this is absolutely crucial, securely migrating all your credentials into the new platform's native secret manager.
And this brilliantly illustrates a universal truth. No matter which tool you actually choose, your success depends on core engineering principles. You always want your pipelines to fail fast, meaning you run your quick linchers and unit tests first so you don't waste time. You should always parallelize independent jobs. You have to aggressively cache your dependencies so you aren't re-downloading the entire internet on every single build. And finally, always enforce the principle of least privilege for your CI/CD credentials.
Which brings us to our final slide, and a question I really want to leave you with today. In a 2026 landscape absolutely filled with zero setup managed cloud-native tools, you have to look inward at your own organization. Is Jenkins' absolute, unmatched flexibility really worth the operational overhead of managing your own infrastructure? For complex enterprises, the answer is often a resounding yes. For fast-moving startups, maybe not. You really have to weigh your desire for ultimate control against the sheer convenience of modern managed alternatives. Figure that out, and you'll find the perfect conductor for your DevOps orchestra. Thank you so much for joining me for this explainer. Keep learning, keep building, and I'll catch you next time.